So balancing redox reactions in a basic solution is very similar to the way we do it in acidic solutions, except we're going to add some things after we balance the reaction. So you balance it exactly the same as in acidic solutions, and then at the very end we're going to change our hydrogen ions into hydroxide ions. And to do that, you add hydroxide to both sides of the reaction, and then the side that has the hydrogen ions actually combines to form water. And then if there's water on both sides of the reaction, then you can cancel those out. So we're going to go over 3 problems. So the first thing that we want to do is write our oxidation numbers. Bromine by itself is 0. Oxygen is a -2. There's 3 of them, so that's a total of -6. So in order to have a -1 left over, bromine would have to be a +5. Bromine by itself has the charge that is written next to it. So we have bromine that is being oxidized and reduced. So if bromine goes to BrO3, the oxidation number is going up, which means it lost electrons. And so when you lose electrons, that's oxidation. And then bromine is gaining electrons. The oxidation number is going down. It's gaining electrons, so that is reduction. So we write out the half reaction, and it doesn't matter which one you start with. First, we want to balance the bromine. There's 2 bromines, so we're going to put a coefficient 2. That gives us 6 oxygens, so we're going to want to add 6 water. That's 12 hydrogens, so we'll want to add 12 hydrogen ions. And then we have to look at the charges. We have neutral on this side, 2 negative and 12 positive, so that's a +10, so we would need 10 electrons being lost. This is our oxidation half reaction, so the electrons should be on the product side. Now we're going to do the other half reaction, so Br2 goes to Br-. There's 2 bromines, so we'll need to put a 2 there. That gives us 2 negative, so we're going to need to gain 2 electrons. Now we need to balance our electrons. We've lost 10 but only gained 2, so we're going to multiply this reaction by 5. And then our electrons would cancel, which is what we want. Nothing else is in common, so we can't do anything but add this reaction together. So we have 6H2O plus Br2, and then 1 and 5, that would be 6 total. All right, so we've balanced the reaction like it was in an acidic solution. Now we need to turn it into a basic solution, and so to do that, we're going to cancel out the hydrogen ions with hydroxide ions, because hydroxide would be basic, where hydrogen is acidic. So we have 12 hydrogens. That means we're going to need to add 12 hydroxide ions to both sides of the reaction. All right, so we've added our 12 hydroxides to both sides. Hydrogen and hydroxide make water. So we're going to combine these, and we're going to say that that is 12 waters. So the subscript 2 is coming from the one hydrogen from the hydrogen ion and the other one from the hydroxide ion. So you just take the coefficient and then make water. Now we have 12 waters on the product side and 6 waters on the reactant side. So these 6 can cancel out 6 of the 12 on the other side. So we can cancel those 6 and we can change that to 6. So then if we want to rewrite this so that it's nice and clean, we would say that the balanced reaction is 12 hydroxides plus 6 Br2 goes to 2 BrO3 minus, 10 Br minus 6 waters. So again, you're balancing the same way in as acidic, and then at the end you're adding in this hydroxide piece. Let's look at another problem. All right, the first thing that we want to do is do our oxidation numbers. Silver is 0, zinc is +2 because of the charge, oxygen is -2. There's 2 silvers, so instead of silver being +2, it's going to be +1 because we're dividing by the subscript, and then zinc here is 0. So silver goes from 0 to +1, so the oxidation number has gone up, which means it lost electrons. So oil rig, that means it's oxidation. Zinc, the oxidation number decreases, which means it gained electrons. Again, oil rig, gain electrons is reduction. So then we're going to write our half reaction. Silver goes to silver oxide. We have 2 silvers, so we'll want to balance that. We have 1 oxygen, so we need 1 water, which gives us 2 hydrogen ions on this side. Balance the electrons. This side is neutral. This side has a charge of +2, so we're going to add 2 electrons. Silver was being oxidized, so the electrons have to go on the product side. Now we're going to do the zinc one. So zinc 2+ goes to zinc. +2, so we would need 2 negative on this side to equal the neutral that the product side has. Zinc was reduced, so the electrons should be gained, so the electrons have to go on the reactant side. They're already the same number of electrons, so we don't have to worry about balancing, and these 2 will cancel these 2. There's nothing else in common, so then we add it together. Water, 2 silvers, zinc, Ag2O, zinc, and our 2 hydrogen ions. So because it's in a basic solution, we're going to add our hydroxide, and we want to add the same amount of hydroxide that we have as hydrogen. So since we have 2 hydrogen ions, we're going to add 2 hydroxide ions to both sides. Our 2 hydrogen and hydroxide ions then will combine to form 2 waters. And then we can cancel out one of these waters because of the water on the reactant side. And then we can just rewrite it so it's nice and neat. 2 hydroxide, 2 silver, zinc ion goes to silver oxide, zinc, and water. Balance like it's acidic, add hydroxides to both sides, and then cancel out the waters. One more example. Oxidation numbers first. Hydrogen +1 because it's with a nonmetal, that's a total of +3, so nitrogen will be -3. Oxygen is a -2, there's a negative charge, so chlorine will be a +1. Hydrogen is +1, there's 4 of those, so that's a total of +4. So we need nitrogen to be -4, but there's 2 of them, so it's going to be -2. And then chlorine is going to equal the charge. So nitrogen is going from -3 to -3 to -2, so the oxidation number has gone up. So it lost electrons, which means it's oxidation. Chlorine goes from +1 to -1, so the oxidation number has gone down, which means it gained electrons, so that is reduction. And then we're going to write our half reactions. NH3 is going to N2H4. 2 nitrogens, 1 nitrogen, so we're going to put a 2 there. There's no oxygens to balance, so then we have to look at our hydrogens. 2 times 3 is 6, so we have 6 hydrogens and only 4 hydrogens, so we're going to have to add 2 hydrogen ions. To balance it, it's oxidation, so the electrons have to go on the product side. We have a positive 2 and the reactant side is neutral, so we need 2 electrons to make this side neutral. Then we can look at our chlorine. So 1 chlorine, 1 oxygen, so we'll have to add a water. That gives us 2 hydrogens, so we'll have to add hydrogen ion. So we have +2 and a -1, so that's still positive on this side, and then we have a negative on this side. So it's being reduced, so the electrons go on the reactant side, and we would need 2 electrons to give us an overall negative charge to balance the negative charge over here. The electrons are equal, so they will cancel out, so we don't have to multiply. There is nothing, the hydrogen ions are in common, so we can cancel those as well. And then we can combine the reactions, so 2 ammonia plus ClO minus and 2H4, Cl minus, and water. Notice that this one didn't end up having any hydrogen ions, so we don't actually have to do anything, and regardless of if it's in a basic solution or an acidic solution, we would end up with the same answer here because those hydrogen ions would cancel out. Make sure you fill out the Google form and try those problems from the textbook.